Yo, what's up? Welcome back to Advent of Code Day 10. I'm having trouble with the shortcut to start recording, so I have started and stopped a couple of times already. So, okay, this problem. We are still on December 10th, and I have given part 2 a little bit of a thought after the last session, the last video, but not that much thought really. The idea that I have is basically the same idea that I had in the previous sitting for this, which is to expand these pipe mazes that we have to like double the resolution or something like that, or maybe triple the resolution, and then doing a fluid fill algorithm to not have to worry about the spaces between the pipes that makes this very tricky, I think. But yeah, this is going to be complex, I think, and it might take a while, so buckle up, I guess. And buckle up, I will. I have put a stopwatch on my cell phone to remind myself to stop at like after an hour or so of coding, just to avoid getting like too dizzy with too many thoughts, or coding for more than an hour. I realized that I get a bit like nonsensical. my brain cannot handle things very well, so I should stop more regularly and take breaks, and I will try to remember to do that. But anyway, let me try to describe what's the idea that I have. So what we have to do in part 2 is to recognize the area inside of this, how do we call them, like pipe loop. Yeah, loop. Okay, so this is a single loop, and it encloses these four actually tiles, and here they are marked. So the ones that are marked with I are the tiles that are enclosed, and everything else is on the outside of the loop, and here it's marked like this is sort of an entrance here for the outside. But the tricky thing is that pipes is like they don't touch, and it's like how do they call it? In fact, there doesn't even need to be a full tile path to the outside of the tile to count as outside the loop. Squeezing between pipes is also allowed. So in this example, this part of the O's, it's also, maybe I can bump the font size here, is also outside the loop, because it's like they can, if you squeeze between these two pipes here, you can get here, so this is on the outside. And that makes this thing very tricky, I think. So I thought about another idea, which was to, okay, what I want to do is probably like a fluid filling algorithm, and probably starting from the outside, because that's the only thing that I know. Like, I don't know what is inside of the loop, enclosed by the loop. That's actually what I want to know. But if we do a fluid filling from the outside, we can fill everything that is not inside, and then calculate, well, what is inside, which is basically what is not outside of the loop, if that makes any sense. So, okay, the idea was, okay, what if we do a fluid filling algorithm, but it's not as naive as just considering each tile? What if, for example, the fluid filling logic would have some idea about the direction that you are fluid filling from? That was a mouthful, fluid filling from. So imagine that you are on this tile, you have fluid filled up to here, and you want to fluid fill down, and there is this pipe, and imagine that also you only have the pipes of the main loop. You clear up all the other pipes that are like junk in this input. This input here doesn't have that junk, but the actual input is this thing it's full of junk pipes. So that we can do pretty easily, because in part 1 we traveled along all the main loop. So we know we can know pretty easily what are all the tiles that correspond to the main loop. So we can discard everything else. And going back to this, it's like, okay, if we are fluid filling down and there's a horizontal pipe here, we know that we cannot pass through that, so that's a barrier. We stop and we can keep fluid filling in the directions that we haven't visited before. But if you're down here, for example, and we try to go up, fluid fill up, there is this L pipe here. So it's like, okay, we can squeeze through here and consider like this thing fluid filled, and then maybe a vertical pipe we can still keep going, and this thing keep going, and that's where this is where things gets a bit complicated, because it's like when you get this turn from down to right, and you come fluid filling from lower down, you should at some point, it's like you cannot keep fluid filling all the pipe itself. At some point you have to also fluid fill this region here. So you sort of have to know in which direction, if you are left of the pipe or right of the pipe in this single tile, to have an idea of whether you can keep fluid filling up or not. And that, I think, is a bit complicated and complex, and I think if we follow this idea, the solution will be super complex. So the next idea that I had is, why don't we like expand, like zoom in on these maps and make every tile a 2x2 drawing of like 2 tiles by 2 tiles, or maybe even 3x3. I think 3x3 actually is a better idea, but we will explore this. So for example, a single horizontal pipe, I actually draw something like this on the previous video. Let's bump the font size here, maybe right in the README. So let's think, for example, a single horizontal pipe. We would map this to something like, and in the expanded version of the map, we are not going to deal with pipes and things like that. We are just going to deal with booleans, like it's present or not. So we map it to a little drawing of 2 non-empty spaces, like 2 filled places and 2 empty places. You know, and if we have something like the say the L, or I don't know what, the 7, which is like going from horizontal or from the left to down, we can map this thing to field, something like, what's the character, this, and then something like this, which, by the way, is this different to a horizontal pipe, to a vertical pipe? Maybe it's not different and I should do a 3x3. Yeah, maybe I should convert these things directly to 3x3, because I was thinking maybe 2x2 would make sense, because if you you know, I was thinking that this should map to something like this, because like the horizontal pipes, we always put them in the top 2 tiles of these 2x2s, and then let's say that the vertical ones, we always put them on the left. So if you have 2 vertical pipes of these kind of characters, and 2 pipes like this, they would map to something like to something like this, you know. And then if you're fluid filling, this is empty here, and the fluid filling algorithm could squeeze between these 2 pipes. That's the thing. But I'm not sure if what would be better, like to blow up to 2x2 or to 3x3. Maybe 3x, like with 3x3, I'm sure that there won't be any wonkiness or edge cases. So maybe we should just blow up to 3 by 3. Actually, let's see the inputs. So this is the 10 inputs go down in size, and the last character here is on column 140, and it also has 140 lines. So yeah, it's tweet sized, I guess, this map. So how much is that? Can we calculate maybe what is 140 times 140? That is 19,000 something. Yeah, this is not such a big number. And if we multiply this, so if we map each tile to a 3 by 3, if we map each tile to a 2 by 2 thing, we will be multiplying the amount of tiles by 4, right? And if we map each one of them to 3 by 3, we are multiplying by 9. So how much is this? 167,000. So it's pretty much nothing for a computer to manage. So yeah, I think maybe mapping to 3 by 3 super tiles would be, like expanded tiles would be better. And then we can, and the idea would be then to run the fluid fill algorithm from the outside, from fill everything, and then sort of reduce that thing again to the original size. And well, you don't need to reduce, but in order to count, it's like you can use the original map to see, okay, is the mapped coordinate of this field or not, and then you can know if what is on the inside and what is not. I think that's kind of the idea. So you can probably tell that I haven't thought this out very well, but that is, I think that this should work basically. And okay, anything else that we want to see? Yeah, probably there are some things that I would like to see. Before trying to, oh wait, I was calculating the size of the map, right? So we also know from the answer I submitted what is the length of the, where is this? Of the snake, and loop. This reminds me of the snake game. So if I say snake, know that I mean the loop. So I don't know why I was using the calculator as an app if we have the awesome system calculator here. But this is the total amount of tiles in the map. So the loop itself is pretty long because this number is half the loop. So if we do 6909 times 2, yeah, of these 19,000 tiles, we already know that 13,000 are occupied by the loop itself, and then some of the other tiles will be on the outside, and some of the other and some will be on the inside. So that's interesting. I don't know why that's important, or if it is important, but okay. And I was saying, okay, yeah, this snake or loop, sorry, is pretty long. I would like to actually know its shape on my input, because it's impossible to look at it. Like if you look at the input, it's like all this mess. If this were using like Unicode characters that for pipes that are actually touching or something, maybe we could see something. But how it is right now, we cannot see anything. So I was thinking maybe we could start there. Like I want to see the shape of our giant loop. Maybe we can start there. Maybe we can make this thing that we already have print the loop itself. Like what are the characters that make up the loop. So actually, if we put the loop here in the console inputs, datetime input. Yeah, maybe if we print it like on something, oof, man, this is too tall. But maybe we are going to see something. If we print it here, you know what I want to do? I want to just print with like colors and see the thing like coloring up. So maybe even animate it while we are looping here. That would be fun, I think. So yeah, let's have some fun first before trying to go for part 2. Yeah, what did we have here? So we have the main loop. We are looping. So after each iteration, you know what? Actually, this is a stupid condition here, because we are asking if the character that we are at is the S character, so the starting character, but we already know the starting position. We have it right here, so we can just ask if we are back at the starting position, basically. This should be the same as before, and if we run check all, yeah, this passes. This is let's add these changes. This is totally uncontroversial, so use start position instead of checking, yeah, if the current char is S, whatever. Sure. So I think after each step I want to print the map and maybe print the loop positions that we already know, print them in a different color. So I also want to mark the positions, or sorry, the loop, yeah, the loop positions on another, because now we are not taking any, we are not storing those. We are just counting steps that we take when looping. But we are going to need to know which are the pipes that correspond to the giant loop. So I think like we could store those things in an array or in a vector, sorry. But if we do that, then it will be difficult to know whether, like, okay, this position in the main loop. So I think I will just have another grid. So let's call it is pipe loop grid even, and this will just be another vector of vector. Actually, we can just initialize it, and let's say this is going to be a vector of, and let's just say booleans maybe, or numbers. Booleans is fine, I guess. So it's going to be a vector of vectors of, everything will be false at the beginning, and the size, well, let's have the width and or height and width of the grid. So let's say height is grid length, and width is grid 0 length, and this of course is going to explode if the grid is empty, but let's not care about that. We even know that the grid is square, so let's just use size here, grid size. Yeah, let's try not to overgeneralize. Okay. Pipe loop. grids. Okay. So now that we have this, we can mark this thing. So we are going to, this is maybe a bit ugly because we have the position X and Y, but should I? Let's do it ugly. Yeah, in an ugly way. So the first coordinate of position is X. So here we want to access by the second one as usize because positions are signed integers. Maybe I should use unsigned integer positions, but okay. And position 0, let's mark it as true. Okay, great. And with this, we should know what are all the positions that are part of the giant pipe loop. Okay, and now I want to print this thing. So let's just put this into a function. So print print frame, let's say, because I'm going to be printing this each frame of an animation. So we're going to pass the grid itself and is pipe loop grid. This name is not very pretty. Let's go with this. Sure. Generate this, please. And I want to extract this into functions to just have something that can skip checking, that I can easily comment out, basically. So this first thing is actually our grid. And should I have another type for this? Well, let's not care about that, but it's not a very nice, well, there it doesn't look so bad. So, okay, it's a grid of booleans, fine. How are we going to print? Well, I want to accumulate things into a giant string probably. So let's say, output route is going to be, do I want a mutable string here? Probably won't, yeah, let's do it with nested for loops and not think about like iterators, logic and things like that. So we're gonna have this, is gonna be a new string. Because in Rust, strings are like the string buffer kind of type. If you make them mutable, you can append things to them. And what do we want to do? Well, we're gonna go for each line, line or row and y coordinate in grids iter. So something like, we want something like this. Let's copy this nested loop. Why reinvent the wheel? We have this, we have each character, fine. And what I want to do is, what do I want to do? Yeah, let's just push things into the string, basically. If the character is S, maybe I want to color that in a special way. I don't care. I don't really care. So we are going to check if, let's say, let is loop parts if is pipe loop grid accessing by y and x. Sure. And if is this thing is loop part blah blah, I want to push a string, and I'm going to use the escape codes for coloring, which I never, of course, remember, and I'm going to have to look this up. Rust print colors to terminal. And they are violet links because I have already looked for, I haven't even upvoted some of this. Awesome. And there is a crate for this, of course, but come on. Oh, this is what I want. Yeah. Octal escape sequences. There is a Oh, we need to do hexadecimal. This is nasty. Okay, but I guess this is saying like error with all of this nastiness. This must be the escape character, and then then you have the color code and all of this, and this is the reset code. Okay, let's copy this mess. And since it's talking about an error here, I would guess that this is red. So let's first push this part. Then we are going to push a single character, which is the character of the grid. So let's copy the reset code. Let's remove this, and then we are going to push the reset part. Something like this, right? I like this because the character is a reference. Okay. With this, we should have each line, and then we can push a new line. So it's a new line like this, and then we can just simply print this thing. Print out, or sorry for the noise. We can do this and wait for a little bit. So how do we wait? Rust thread sleep. There is a sleep milliseconds or something like this, if I remember correctly. Yeah, look at this prettiness. From millis. From millipilis. So we're gonna sleep for, let's say, 10 milliseconds. So it's pretty fast because there is like 6,000. Yes, import this, import thread also. Whoops, import from std thread. And where are you importing this? Yeah. It likes to do this because I put this use directive here. That's ugly. Okay, let's put the imports at the top, how they should be. And will this work? Is this the color that I want? I have no idea. There's only one way to figure this out. We can let's do first cargo run, let's not be so optimistic about the total input. Let's run it with some of the samples. So inputs day 10 sample B, maybe. Oh, it printed something and it's yellow. But we're only printing the characters that are inside the loop. Of course, we also need else we are going to push just the character without any coloring. Okay, so if we run now, Well, that was pretty fast because, but it looks like, look, it's going like that. But of course, yellow is not what I want. So it's 93, I think is one red. Yes, one is red. Beautiful. Let's go with the actual input. It's probably printing something, but I'm not seeing it. And if we make it smaller, oh, look at this, it's going. It's also screen tearing a little bit, but look how densely packed this thing is. It looks like some bloody thing going on. Oh man, it's kind of gruesome. So I love doing this kind of thing. So yeah, we can see how this thing is, well, taking a lot of time to run, but also how it's very, very densely packed. Look at it go. Okay, let's kill this thing. It looks like some blood splatter. And let's not sleep. Well, without sleeping, it goes faster, but it's also printing lots of stuff to the terminal. So I think now the terminal is being the bottleneck of this and taking too long to update. But we can, I want to go, let it go and print everything. So to have an idea of how much of this is covered by this horrible blood stain. Of course, I can also like run the whole thing and print this only once in the end, but I have already run this, so let's see. Okay, so it's going to the right now, and look at this, there's a blotch there in the middle. If that's, is that thing going to stay? How much, how much will we need to like squeeze between pipes? This is going to be difficult. Oh, it's being completed. Oh yes, it's being filled. Oh, there it, okay, look at that. Look at that. You know what that looks like? I don't want to say anything improper, but I was thinking this looks like our thumbnail for this video, of course. If you thought about anything else, you're a dirty-minded person, maybe like me. But anyway, yeah, that doesn't look very nice. But at least we have a confirmation of a couple of things. First, that this thing doesn't really touch the outside. So if we do a fluid filling from the outside in, we are probably safe. I was thinking about if maybe we need to add some padding to the map to like make sure that the fluid filling doesn't get cut by the pipes that go up to up to the border. But maybe it's not a problem for this input, so we don't need to care about that. Okay, awesome. I have this beautiful print frame function, and I'm going to leave this thing here because maybe a similar thing to that can be useful for when we implement the fluid filling, because fluid filling can be tricky, I think, and maybe it will be nice to have some visual representation to see how the thing is filling up. But this thing is so packed that if I zoom in, it's like, man, looking at this thing and realizing, okay, where should we like squeeze in between pipes is, to be honest, it's kind of impossible to my eyes to see it here. So look at this. This is like modern art. It's a bloody thing. I'm glad that I used red. But okay, let's comment this out and can we allow that code. Yeah, don't. And yes, of course, the duration is not being used, so that is fine. Knowing how to print stuff is already good enough. Okay, so we have an idea of the general shape of things. Great, and we are also marking these booleans of where the main pipe loop is. Great. Great. So what should we do next? There is quite a few things that we actually need to do even before we start like fluid filling. One is to expand the grid for sure. So we need to get this grid and we need to expand it. But before that, we also need to clean the grid, I think, because if you look at this, the outside of this is filled with other pipes and things. It's not just empty ground. So and of course this is done so the answer to part one is not trivial. It's like you're not just counting the amount of pipes and dividing by 2. You have to follow the pipes along, and you have to not get confused by all of the junk pipes that are lying around. But now for part 2, all of these things are on the out, like we have to not consider all of these things. And even inside, like some of these things that we see here are inside of the main loop, are enclosed by it. But we don't even know which ones they are, because as you can see, for example, here, this one is not inside, because you can squeeze in between this J and this F pipes, bends, and you can squeeze in here. And maybe you can squeeze in here too. But all of these are not empty ground. This is empty, for example, but these are also like junk pipes that are lying around. And I want to clean all of this up before doing the flood fill. Because if we do this expansion of the grid, maybe these things won't bother us, because they will also be expanded, and the water, the fluid filling algorithm can also get between these things. But if some of these pipes laying around also form some loop somewhere, the fluid filling algorithm won't get into those loops, and it's gonna mess us over. And I wouldn't be surprised if the creator of Advent of Code has created some loops somewhere else in this thing too. So we have to clean the thing up. So actually, let me take notes of these things in the README. Let's say to do, I'm going to clean up grid of chunk pipes, expand the grid, and what else do we need to do? Something else that we need to do is we have to realize what is behind the starting position, the S. So the S character means that there is a pipe behind the S, and for example, in this example, it's a pipe that comes from below, like that connects down to west or to the right. And we have to know this and fill in this thing with the actual pipe that goes here. So that's also part of the thing that we need to do, because otherwise we don't know what pipe is below the S, and the fluid filling can get inside of the, or maybe we don't know to do. We don't need to deal with, like, to actually realize what pipe is below it, but we definitely need to take care of this S. Take care of S, and then do the fluid fill. Okay, so that's what we need to do. And we need to take care of this maybe before expanding the grid. Okay, so let's now clean up the grid of junk pipes. So how are we going to do this? Well, after we have done part 1, we want to is pipe loop grid. I want to call this thing somehow, like somewhat, you know, that makes sense. Is pipe loop. Yeah, this is fine. I mean, I don't like the name, but it is a bit at least explicit. So let's now do something like let's cleaned grid is going to be, so let's annotate this as all of this is part 1. Now we are starting, just now starting part 2. Let's say clean grid, or clean up grid. Let's use correct English, please. We're gonna pass the grid and pass the is blah 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 grid. Okay, we are going to clean it up. That means we are going to just remove all the junk, right? Do we need to do this actually? Do we need to do this? Yeah, maybe we do. I'm not really sure. Let's say we do. Let's imagine that we do. I'm not entirely sure, but yeah, because we need to preserve the pipes information for part 2, for when we need to expand this thing. But I'm actually not entirely sure. Let me think for a bit. When we clean this thing, we are going to leave ground everywhere that is not on the giant loop. Yeah, let's call it loop, you know, like loop is going to be the main. So let's call this thing simply is loop, well, grid, yeah. Okay. And even here, so yeah, this thing is also. Okay, clean up. I'm thinking whether we actually need to clean this, considering if we need to clean this up or not. Maybe we don't, you know? Maybe we don't. Huh. I am wondering. Let's see what happens if we don't. Let's see what happens. Let's just go for it and try to expand this grid. So let's say expanded grid. So I took notes of all of this, and I'm just going to skip this too and just go for expanding the grid and then do the fluid fill. Okay, so what do we need to do? We have to expand this grid, do the flute filling thing, and then count. What are we going to do then? We want to count how many of the original tiles are not filled by the flute fill and are not part of the thing of the loop. That's sort of what we. So we need to do the flute fill, and then afterwards we have to like count area, like inside area, I guess. Okay. So it expanded. Let's say expand grid now. Okay, and we are going to pass the same kind of thing that we were passing before. That is the information that we need. Actually, we don't need to pass. We don't need to pass whether we are, like, if we don't need to clean this up, we don't need to pass. Like, this is information for cleaning this up and for then doing the flute fill. Actually, do we? Maybe we don't need. Maybe we don't even need this. I don't know. It depends on whether there are other loops or not. But we are going to realize that at some point, I guess. So let's generate this and move it to the bottom or to somewhere that it makes sense. I guess here before printing shit. How are we going to expand the grids? And this is, of course, the grid. And it's going to give me back another grid, but this time it's going to be a grid of what? I'm gonna say just a grid of bytes. Yeah. Or even bools. So in this grid, we want to have like what is we want to know like what is like empty, what is a wall that we want flute fill, and then we are going to like sort of flute fill this thing. So I think 3 states is what we want. But let's just use constants instead of an enum, and then we can think about that later. So let's say let the result be a vector of vectors of and we need the size, so let's say let's size be grid length. Sure, we're gonna again assume that this is a square thing, so and here we're gonna multiply by 3, and let's just bite the bullet and expand this thing by 3 in length, so this is 9 times the amount of the tiles that we had before. And let's initialize it all with zeros. Okay, then we are gonna do this kind of loop that we are happily copy pasting, iterating each row and each XY position. And then we are going to match the character. So let's match the character. And do we have something? Well, we have the description of the. Let's close everything up here. And the description of the thing with all the symbols that we need to care about. Yes. So, if this thing is a pipe, we are going to draw. What are we going to draw? what do we want here? We want I want to map each of these to like their 3x3 super tile, expanded tile, let's say. So say let's expand the tile B, the result of this match, and this first one, let's just draw it with ones and zeros. Okay, so it's gonna be this like this, but of course this Rust analyzer wants to, or the formatter wants to collapse this thing, so we'll just add a little comment here so it doesn't get collapsed. That is a nice hack. Is this fine? Yeah, right? I think this is fine. We could also use a string or something like that, but let's go with this. Let's go with this. Horizontal pipe is going to be something like this. Yes. Then what else do we have? It's actually draw ones with just zeros. And I'm going to copy this and then just use that. Okay, so in the description, have the L then. L is going to be ones in these places. Then we're going to have what? The J is going to be ones in these places. Then we're gonna have the 7. The 7 is going to be ones in these places. So you can see that how a horizontal pipe then a 7 is going to touch, the ones are going to touch the ones in here. So that's nice, that's what we want. Then these, what follows, the F, of course, is going to be ones in these places. Beautiful. But we keep going. Then we have the dots, which is empty space. And this is just going to be all zeros. And it's kind of ugly that I need that, but okay. And the other possible character is the S. And for the S, I'm actually thinking, let's just fill in with ones. I think this might work, just filling with Y's, because yeah, what is that going to do? This is going to, well, make this all walls, but it's just, I don't care about what the pipe below this is. The water or the fluid can squeeze in between this and whatever is on its side. So I think this is fine for, yeah. As long as the S is not in the top right or top left corner or wherever we are going to be starting our fluid filling from, I think that's going to be fine. We're gonna be fine, yeah. It's fine, don't worry. And of course, this is a non-exhaustive match because we are not using proper modeling of things. So let's say that this is unreachable, or just return an error, I guess. What did I say in previous videos about parse don't validate? I didn't parse, so I'm validating. Unexpected character. And we're gonna early return this, so it means we need to do an OK result here. And this thing is going to need to be an AOC result. Yay, result propagation. And with this, the call to expand grid, let's short circuit this, and we should have an expanded grid now. Okay? Beautiful, beautiful, beautiful thing. Okay, let's actually see if this grid expansion makes some sense for some sample input. Of course, not for the actual input. We have sample A and sample B, and these are more complex that I want. Actually, why is sample B simpler than sample A? Did I mean to? Yeah, I think I meant to use sample. Okay, this is the same loop as before. Wait, what is this? Ah, this is the small square. It's just that it's filled with other junk around. So let's actually expand the sample A and print this. So I'm going to print the expanded grid. Oh, expanded tile, but we aren't. We haven't finished expanding the thing. I just assumed that we did. But now that we have the expanded tile, we need to put this into the expanded grid. So let's not call it result. Let's call this thing expanded grid, of course. And what are we going to do? Well, we are going to basically iterate this expanded tile, right? So let's say for we just want to write into the expanded grid. So for I in 0 to 3 and for x in 0 to 3. Now this is not I and x because we're still going to need the outer x and y. I said I meant y. Y expanded, or what is this? This is the xy in this tile. Okay, so tile, yeah, tile y and tile x. Beautiful. So we are going to put in the expanded grid at y times 3 plus the tile y, and then at x times 3 plus the tile x, we're going to say well, expanded tile tile y and tile x. That is kind of a mouthful, and you don't like this because it's not mutable, of course. Let's make it mutable. And you don't complain now. Okay. And let's just now print the expanded tile, and we are going to copy our trusty nested for loops. Let's just print this here, but we are not going to go over the actual grid. We're going to go over the expanded grid. So this is going to be bigger. And now what are we going to say? It's not a character, it's let's call it I don't know, tile expanded tile, whatever, tile. If the tile, what are we going to do now? We want to print this thing. So let's, again, to have a string output. So let's mute out be a string new. Beautiful. If the tile is 0, let's have a dot. Otherwise, let's have a hash symbol, and this is what we are going to push into out. So out, push this thing, okay? And this surely needs some dereferencing. What is this? What? Expanded grid? No, it's the row that I want to, okay? Yeah, now it's correct. And we don't need XY. Why was I thinking that I need it? I don't, right? I don't need it. So let's just have the row, don't zip, row and tile. This is better. And after this, we push a new line, and then let's print line the this string. Okay. Let's run in this console with the sample A, please. And look at this. We can see the, maybe if we bump the size, we can see the enclosed loop. This was the square loop that we had. And we can also see that if we start float filling from here, it looks like we would float fill everything else, which is nice. That is nice. Okay. So I think we have successfully expanded our grid. Let's do this same thing, but lower the font size. But for the second sample, oh, look at this. This is even better. So we can bump this, and you can see here pretty clearly that if we float fill the outside, the inside won't be touched. So we will be able to know what is on the inside after float filling, and that's gonna be great, I think. Yeah. Awesome. So that's nice. This expanded grid is nice. We can comment this out. I'm not going to try to print the expanded grid for the actual input, but because that's going to be super huge. Oh, and it's an hour already, so maybe I should be taking a break, but we have at least expanded our original grid with the pipes. That is nice. And you know what? I'm now even thinking that if we had this grid expansion like this, this expanded thing, we could even like float fill like the other way. Here the hash symbols, we could do a float filling algorithm to actually like fill this thing, the loop itself, and maybe even implement part 1 with float filling and with the expanded grid. That is a far-fetched idea, but I always like to like simplify logic and use the part 2 solution for part 1, but we don't even have the part 2 solution, so I shouldn't be heading along. How to say, adelantarme. I'm making a blank here, speaking in English. I shouldn't rush ahead of myself. for this. I'm sort of tempted to continue and try to do the actual fluid filling thing, but let's actually maybe call this thing, because this is like a nice thing to extract here. Extract this into a little function, and we're going to call this thing expand. Oops, expand char, but I touched something wrong. And let's go again. Expand char. Or tile. Let's call it tile. That's better. So we're not modeling tiles with an actual enum, but we're using chars for this. It's gonna return a result of just 3x3 vector. That's fine. And that's it. And we are expanding this for sure. Awesome. And then we are writing that into the expanded grid, which is also nice. So this function doesn't look so gnarly as before, and this only does one thing, which is expanding the character. And this is nice. This is a nice. Okay. Okay. What else? Do I want to do the fluid filling now? No, I think I will take a break and do the fluid filling later. So this is not just to make leave a cliffhanger after at the end of the video. It's just to not be so foggy when doing the fluid fill thing. And we don't like, we need to do the fluid filling, and then we need to like contract the fluid fill grid into something that we can count. So maybe that will take some effort too. So yeah, let's take a break now. So if you have been watching so far, thank you very much for following along, and see you later. Bye bye.